Hello, and welcome to Virtual Investor Conferences. On behalf of OTC Markets, we're very pleased you joined the Clean Energy Metals Conference. Our next presentation is from Talga Group. Please note you may submit questions for the presenter in the box to the left of the slides, and you can view a company's availability for one-on-one meetings by clicking Book a Meeting in the top toolbar. At this point, I'm very pleased to welcome Mark Thompson. He's the founder and managing director of Talga Group, which trades in the OTCQX Best Market under the symbol TLGRF and on the ASX under the symbol TLG. Welcome, Mark.
Thanks, John. Appreciate it. Thanks for the opportunity to OTC. Glad to catch up with all of our shareholders in the US time zone there. Let me commence to introduce Talga Group. Primarily, we're about producing high performance and sustainable graphite materials using our own technologies. And in this case, we talk about new energy, meaning batteries, but that also means graphene for advanced materials, as well as really high performance anodes. But mostly everything is based around graphite as a material. And that's essentially what you have got with Talga. We've been around for about 15 years now. We're listed both on the ASX, as John mentioned, and on the OTC under TLGRF. We have a market capitalization of just under $250 million Australian. The details are here for you, and certainly I invite you to look at our research coverage from various brokers in Australia and internationally for details about our projects and the various valuations that the analysts have. And also we expect to see some coverage in the US very soon. Down here on the share price, you can see we're sort of coming off some quite historical lows, along with a lot of other battery related materials in the last few years. But you might notice on the right-hand side of that chart, a bit of an uptick in volume happening. So there has been some recent changes that I'll speak to later on in the presentation that seem to be attracting some attention that's just starting out. So where are we at the moment? Well, we floated in Australia in 2010. I floated the company on some gold prospects, but really what I was interested in was getting exposure to the mega trend, which was batteries. You could tell that lithium-ion batteries were going to be this multi-decadal growth area. And so that's what I shifted to Sweden for, and by 2012 we started setting up there. We found one of the world's highest grade graphite deposits there, and we've started developing that. By 2022, we were building and commissioning Europe's first ever coated anode plant. So we was actually making anode from graphite. So fully integrated from mine to anode, operating over there. So in Sweden, in Stockholm, you have our head office. Up in Luleå is where our planned initial gigafactory is for anode production. Up in near Kiruna in Vittangi is our main mining center up there. Down in Germany, we've been developing our own wholly owned processing capability. And in the UK, sounds a bit spread out, but these are all for good reasons behind the scenes. In the UK, our battery center of excellence is in Cambridge, where we have access to some wonderful people and science and technology there. So that's where our R&D mostly takes place. And we have a bunch of management system certifications there that you can see regarding our qualifications. So that's just a bit of background on the company. And I guess you could say, well, what's this got to do with the OTC and being exposed in America? Well, I guess I'll go into some more details later, except to say that Talga's at a stage now where it can expand globally, and America is one of the markets that we are looking like expanding to, with details to come. So what do we do? Again, what has the graphite got to do with? Well, primarily it's about the anode for lithium-ion batteries. We're planning to build fairly low cost and very sustainable, very high performance lithium-ion anode materials. We own all of our technology, so we don't copy historical norms that have been developed in Asia, for example. And we have a very modular design of the way we build anode material. And this means that we can duplicate it in different parts of the world based on our existing engineering designs. The site you see here in the background of this picture is all to do with our site that's planned in Luleå in North Sweden. And we're reviewing new sites in the US, the Middle East, Japan, and also even Australia. But yeah, this is the sort of operation that you end up seeing, and these things are fully permitted and under development at the moment. Currently, we already operate, as I said, we've built and operated a coated anode plant. So we already make samples for qualification at commercial scale to various customers, hundreds of customers under commercial agreements and in confidence agreements. We have our own QC and QA regarding that. So this is not just a plan, and it's not just a pilot that utilizes academia or some sort of university situation. It's actually entirely built or ready to scale up to full-scale commerciality in whatever site is required. So let's just take a step back and introduce you. If you don't understand about graphite, like why would anyone care? What's different? Well, for 400 years, graphite was used for things like pencils and thousands of industrial uses, okay? Lubricants, mostly refractories. It's mostly heavily used in the steel industry and a lot of different industrial purposes, and it grows, those markets grow at the normal rate the economics grow, like around GDP. However, batteries is a new use. About 40 years ago, they discovered that graphite, which has these individual layers of highly crystalline carbon, conducts electricity like crazy, but it also allows lithium ions to nestle within it and intercalate, and it holds it. And so it forms the lungs. Essentially, you can push electricity into the layers of graphite and then they come back out again when you use the battery. So lithium-ion batteries of different chemistries. Here you can see an LFP, a lithium iron phosphate, a nickel cobalt aluminium, like you see in the higher performance Teslas, and then MC811, which is quite high performance as well. About half of the active materials in the battery is actually graphite, and 95% of the anode is graphite. So this is highly refined material that's actually a much larger volume part, in fact, the largest part of lithium-ion batteries when it comes to volume of mineral. And yet it's still relatively unknown. So why would we care? Well, the market's growing really fast. In fact, if you go back a couple of years, you'll see that the classic hockey stick you see here on the right has actually been exceeded if you go back and compare to what people thought was happening. So this, up until the very last column on the right, that's all actual growth. So you have been seeing exponential growth. And the important thing is then, by glancing to the left of this slide, is to do with the fact that obviously the more batteries you need, the more graphite you need. And this growth is exponential in different markets. So when EVs are selling less well, you actually get more in battery energy storage systems. When the battery energy storage systems aren't going, you get them in buses and trucks and heavy machinery. And there's a growing interest for military and defense. AI warehouses, the amount of robots needed now for pushing things around in warehouses, these all rely on batteries. So battery growth is bigger than just electric vehicles, is the point, and the market is growing really, really fast. The other thing that's changing quite a lot is, I guess, the geopolitical scene. So the requirement for defense in the past didn't really include thinking about where battery materials came from. So while you could have drones, say, made in the US or made in Australia or made in Europe, the actual things that are powering the electric drones are actually batteries entirely made in China or materials totally made in China. So it's been recognized by the Hague Institute that when you look at across all the different minerals involved in the defense supply chain, the graphite is the #1 at most risk mineral, which may surprise a lot of people compared to the more exotic rare earths and things. But it's the most consistently critical material across almost every application. And there is a growing interest and growing use of batteries. For example, everyone thinks about drones and unmanned vehicles and robots and things like that. But even ammunition has got graphite powders in it. And you're actually, as someone in the field, as compared to a robot, a person in the field could have as many as 70 different battery types on them, from laser rangefinders to night vision goggles, you name it. Currently, all of those things represent a weak point strategically. All those materials are almost entirely controlled by China, and that's changing. Speaking of that, here is the problem. The use of batteries is going up. The use of batteries in defense and strategic sources is going up. Almost everything in the world is electrifying, and yet the source of half of that battery material, which is graphite, and in this case we'll just talk about natural graphite, is there's almost nothing. If you look on the left-hand side here, you'll see there's no production in America at all. There's some imports from Mexico and Canada, very, very little. Same with Europe, almost zero. So effectively, and all the rest of the world, all those materials go to China for processing. So effectively you have zero in the largest, most developed economies in the world. The second problem is that by the time that graphite gets turned into anode materials ready for battery, it's even worse. It's nearly 100% reliance on China. The situation is even worse than rare earths. So not only natural graphite shaping and coated material ends up, which comes out of Japan and Korea, is actually sourced from China. And most synthetic graphite is all sourced from China. Synthetic graphite is fossil fuel based. It's extremely high emissions. It takes extremely high temperatures over long periods of time. And it's basically, it's fossil fuel products. So you're basically cooking up coal and oil to try and make lithium-ion batteries to electrify society. Doesn't make a lot of sense. So you've got this situation where all of the control is elsewhere, and that supply chain is really bad. So here comes Talga with the solution. What is that? Well, we've actually created essentially the same quality as a Mitsubishi or a Hitachi or a Shanshan or a BTR, where you've got a anode production ready to go to a cell manufacturer that's 100% controlled supply chain. So from mined material or recycled graphite, we conduct all the purification, shaping, and coating to make final anode products. So all of our own technology, all our own innovation, been already operating at commercial scale, already qualified and working in products that are with customers at the moment. So that's what Talga does, fully vertically integrated, which is a rare and powerful place to be. What is that capability? Well, apart from just being integrated, the fact is that the information and the technology along that supply chain, the software and everything, is actually Talga's know-how and the competence knowing how to do it. Raw materials, not so difficult. Many places are famous for mining. What's hard is to do the downstream. So we've now got the ability to essentially duplicate what you're currently getting from Asia, but we can do it from Europe, or we could do it within other countries as well by localizing to recycled and other natural graphite suppliers. So we have this in-house capability all the way from the geology and everything that goes with that, to do with stakeholder management, to do with mining and processing, all the way to electrochemistry and actually integrating with making anode materials for end users. So it's a bit of a diamond in the rough that way. What differentiates us from others? Well, number one, the security of having 100% control over that supply chain. Most mineral production for anything, not just batteries, but almost anything, has got multiple steps that are controlled by different parties. We have ownership of our control of our whole supply chain. Secondly, as part of that security, it's our own tech as well, by the way. So we're not licensing things from other people. Additionally, we make high performance products. So we don't just make bulk material that can go into cheap EVs. We're talking about things that can charge, from 0 to 100 in 5 minutes or less. We're talking about things that can do really, really high charge rates and have got can work at super low temperatures. So anything that's power intensive and fast charge, we're very good at. We have award-winning technology. We've been awarded strategic project status by the EU Commission. And of course, we offer reshoring ability. So we're not just stuck to one mine and one part of the world with the subsequent dangers of shipping being cut off, which you would have experienced during COVID, and you will experience again under various guises of geopolitical issues. And importantly, we have 92% less emissions than most common anode making materials. So that's been proven with our mined material, and also there are numbers out there showing similar with our recycled materials. So it's cleaner, it's greener, it's more secure. It can come to your backyard, and you've got the one-stop shop for the whole thing, so you don't have patent issues and things like that. So, okay, let's look at some of the data behind it. So here's just a little bit on the CO2 side of things. Seeing as this is a clean energy conference, we thought we should definitely include something on that, showing that synthetic from China is at least 23 kilos of CO2 equivalent per kilo of anode. Now, the kilo, change it to ton, doesn't matter, the ratio is the same. 23 tons of CO2 equivalent per ton of Talga type material. In fact, 85% of our emissions is from our suppliers. It's not actually from us. So there's a lot of improvements to be done there. So there's actually a real ability to get towards net zero ultimately. From a cost point of view, and this is very important in that there's a lot of talk about how Western companies with their modern safety and environmental regulations can't compete for cost. Talga's in a fairly unique position in that our natural resource assets, our technology, which has extremely low losses, pretty much global leading on low losses of natural material, low energy costs where we operate, and by owning all of the supply chain, that vertical integration allows us to be in the lowest quartile, in fact, the lowest decile of producers of anode production. It's not about raw material graphite production. It's about the final anode. Only the anode is in the battery. And that's another thing between anode and graphite. The graphite as anode goes in the battery. Raw graphite can go to all sorts of things. We're focused on anodes, and we're extremely low cost in producing those. Some recent news, which I'll dash through to, I guess, leave some time for questions as well that are coming up, is that the recyclability of graphite up until now wasn't really possible. It wasn't possible technically, and it wasn't possible commercially. And that means from end-of-life batteries as well. There's two types of recycled material that come out of people that are chopping up lithium-ion batteries. And they make a black mass, they make some concentration of metals. And they're either going to use a temperature route or a hydrometallurgical route. The temperature route tends to burn stuff off. You don't get graphite or any useful things out of it. On the wet side, on the hydrometallurgical side, they can make a concentrate of the graphite and provide that to us. Now, that material is extremely contaminated. If it comes from production scrap, from making batteries, it's actually not bad. It's pretty clean. Lots of people can deal with that. But from a used battery, it's got plastics in it, it's got intercalated, all sorts of different minerals and things in it. It's actually really messed up. And up until now, it hasn't really been technically feasible to do. We have discovered over the last 2 years of research and work, and now we've piloted it and done feasibility studies, that we can purify and then shape and coat that material to make used graphite anode from black mass supply back into an anode that works like a new synthetic anode. Now, the important thing about this is not just from an environmental and clean point of view. It's actually from a strategic point of view. That means that all the batteries you're currently importing from Asia that are filled with Chinese synthetic graphite, you can keep them in the country. Over time, you can build stockpiles of them, you can process it, and you can make batteries again from material that's now onshored in your country. So that's important. Strategically, it can now locate. You can have anode supply starting up within whatever country you want from any black mass supply that you've got, in addition to any other suppliers of natural material that are around. And this is what the process looks like. On the left, if you haven't seen one before, this is what the anode looks like this is in your phone, this is in your laptop, it's in your car, it's in your electric bus, it's in your Tesla Powerwall out the back of the house, it's in the microgrid that you don't see, that's backing up all your data to one of Google's servers right now. It's in the AI warehouse where little robots are shoving your Amazon books around, being delivered, well, hopefully books. That's what anode looks like. And the black stuff's on top of the copper foil. So that's production scrap. But you can also get end-of-life material, which looks worse than that. So that black mass concentrate, all the production scrap, ends up as a graphite concentrate, and then we purify that, we shape it, and you can see the before and after, and we get high capacity, and we get really good first cycle efficiency, which is FCE. Okay, so this has been, quite a big deal, quite a surprise to me. I did not think it was going to be technically and commercially possible, but it turns out that a lot of the challenges we faced in the natural graphite world with our deposit in Sweden that we solved over many years, turns out that it's perfect for having the same effect on these heavily contaminated materials. And so this will allow us to go elsewhere in the world. Speaking of global opportunity. Okay, so before I run through the text, let's look at the right. You've got a deficit currently in ex-China supply. So China for the last few years has been dumping excess amounts of synthetic graphite into the world, dropping the price down to where it doesn't incentivize new production from the West, and it's been predominantly synthetic graphite. Traditionally, anodes for lithium-ion batteries are about 50% natural, 50% synthetic, but now it's dropped into mostly synthetic because that's cheap. Over time, if you do not want to use Chinese material, well, frankly, you're in trouble. There's not enough supply in the West because no one's ever made any in the West, frankly. It's fairly new. So there's actually a very large deficit from supply of anode in the West compared to what the demand is if you're not using Chinese material. And that, of course, is the trend. So what our ability is and the opportunity for Talga and its shareholders is to capitalize both on the growing amounts of waste that exist in the world from recycled material and our really high quality natural sources, and produce anode into what is now a massive deficit of non-Chinese anode supply. That's the basic economic provision of everything. What makes it better for Talga to do than some sort of startup or anyone else is that we can leverage what we already have. We've already got plant designs that are engineered under DFS and front-end engineering and design studies. So this is already designed and the pilots have already been built and the demonstration plants are built and run and produce material over the last 3 years that's out there with customers, and some of it's in the market. And we can scale that up wherever you want in the world, wherever that supply exists. So if you do not want to continue being reliant on those Chinese imports, you can now get it from Talga basically to set up a local production facility with you. We will collaborate with partners and governments to reshore that supply for you to make it. And it'll be cleaner and it will provide you with your own anode supplies, which frankly you've never had before. So in summary, what's the value proposition? Well, number one, if you're not into batteries and strategic minerals, critical minerals, supplies of things that actually build your world, then, stop watching, obviously. You would have stopped already. But if you do care about the fundamentals of the things in your society, the growth market in batteries and electrification is a big part of it. So ex-China supply of graphite and anode is essentially a situation that's currently worse than rare earths and will have to follow a similar path, if you gather my meaning there. Talga is one of the most advanced players in the world. We've already been building anodes and selling anode material for the last 3 years. We're very strategic in that we've got the largest and best graphite supply in all of Europe, and we can apply the same technologies in other parts of the world. By going flexible with our modular production units, we can go wherever the demand is. The fundamentals of our technology is low cost. It's always been designed around innovative processes which are wholly owned and accredited. We have pretty advanced funding on the European side, and we're very, very interested in working more closely with other governments and institutions and partners on how to build further capacity elsewhere around the world. Everything we do is undercut by responsibility towards the environment and sustainability, which is not just is very measurable, and we're actually capable of doing it because we have that sort of know-how. So at that point, I'll get around to, there's quite a few questions coming in. I'll just leave this up for a second, but obviously you can find us on our website, and we have contact points in various parts around the globe. And at this point, I'd better, I'll come back up and let's get stuck into some questions. So there's quite a lot coming in, sorry. The US administration, one of the questions is, the US administration is keen to secure critical mineral supply chains. Is this something you can participate in? Indeed. We are in the early stages. We have been basically developing a US strategy for about 2 years now, reviewing what the opportunities are and sites, looking at sites, meeting people, understanding the supply chain over there, and yeah, I guess you should say that, we'll watch this space. But yes, we think it's actually a really, really good solution for the US. The US has various startups in synthetic and graphite production, but there's not so many capabilities to make anode to actually make what the battery makers need. So yeah, that's what we're going to supply, which will be very good. Another question here is about, has Talnode R, which is our recycled product, been qualified by customers for production? No, it's too early for that. However, it is with customers being tested as we speak, and our own internal test work shows extremely good results. We've published some tidbits around some of the performance, but I guess you should be able to tell that with high energy density, amazingly high first cycle efficiency, and all the other metrics we're seeing, that it's extremely good. We don't say that it's competitive with brand new synthetic for nothing. It's actually, when you think about it, essentially we're reusing what is a synthetic natural mix that's already in the batteries, and we're just cleaning it up and reusing it. The key to that is actually our coating technology. It's purification's critical, but if you purify material, it still doesn't actually make it work as an anode. It's about then the shaping and coating process, and there's some pictures in the presentation about that. But yeah, it's very, very effective material. Timeline for FID is no, we do not have. That's regarding a financial investment decision on the Swedish project, because there is still some minor permitting that we're waiting for to do with the local county administration board and building and rezoning permits, which are with the government bodies. We do not publish an actual timeline on that. We're just hoping that happens as soon as possible. When it does, then a cascade of other things can happen, and yeah, we can get onto that. But over the years, we've learned that that's very, very hard to do. Someone else asked, is there any emerging European competitors? I guess I'm not sure if you mean specifically in anode making or recycling, but in anode making, there are some, I wouldn't say they're competitors. Everyone's capable of making, something in some way, whether they're economic, whether they have the same sustainability, whether they have the same control security-wise. Like, for example, do they own enough of the technology that a military group may be willing to buy what they have, that they get audited and they don't have something that's made somewhere that they don't want? Yeah, I'm not really sure, but no, there's not many. There's not many to choose from at all, actually. So there's very, very little that we know of. And as I said, it's quite a few people doing graphite. There's quite a few people that can do purified graphite or even shaped graphite. That's not so hard either in some ways, but to actually do the coating and make an actual qualified anode material is extremely difficult. And in the past was only ever done by subsidiaries of giant industrial conglomerates. It was never really taken on by anyone from scratch. So yeah, it's a small field, but I would say be careful about people's claims, the difference between active anode material and truly coated active anode material, I guess. Someone else asked, will it be cost or time intensive to begin operations in the US? Will US operations include the similar vertical integration you possess in the Baltics, being a mine, plant, processor, anode creation? Interesting and long question. Let's break that up. Will it be cost time intensive to begin operations in the US? Well, not so much, I would say. For a start, from a time perspective, if you can find a site that's already permitted for various things, that will help, and that they exist. You have chemical parks already, and you have sites that are already permitted in the US. Secondly, you've got some recycled material already providing the sort of material that you'd need to feed that. So you don't need to permit a mine necessarily. You just need to leave the battery recycling to someone else. They need to recognize that they're flushing all this graphite down the drain or burying it or burning it, and that there's either some extra value or they're paying too much to dispose of it and they should give it to you. So there is, I think it'd be a quick supply, relatively quick build, because we're duplicating what we've already been building and designing for some time in the Baltics. So I think the intensity of time and to some degree cost is actually less if you went to the US. On the second part of that question, will it have the same vertical integration? No, it will lack the supply side, being that we don't control who's making that black mass graphite. So we're not doing that. The recyclers who have got somewhat of a checkered history. Some are doing very well, some are not. But anyone that's trying to get metals out of batteries, they'll be in supply of, do they make the do they provide the graphite or not? I would suggest to you that environmentally and economically, there's now motivation for them to do that. I would say that they didn't do it before because they had no one that was willing to buy it or take it because it was too contaminated. So now there's actually a viable opportunity there that didn't exist before, that you'll actually have a maturing of that market that didn't exist, which is a bit exciting. We will go upstream as far as we can, but we don't intend getting in directly into the battery recycling. We're only going to provide that graphite component. And graphite's different because it's not a metal. So it needs a wholly different set of skills to the people that are trying to get nickel, cobalt, lithium. They're all metals. Graphite is not a metal. And so it's more particle engineering. It's more akin to food and pharmaceutical manufacturing and highly engineered particles to get it out. So I think that we will be much more vertically integrated than most, in that we'll be anode making all the way back to concentrate purification, but the very origin will not. What is the ownership makeup of Talga? Insider, institutional, etc.? Good question. Don't get asked that very much anymore. I'm actually still the second largest shareholder as the founder, which after 15 years is somewhat probably remarkable. Institutions, probably in the last few years, in the shrinkage that particularly we've had in the financial industry down here around battery materials, institutional investments, probably between, I'd say, about 5 to 10%, and myself is around 3%. And then we have a long tail of high net worth individuals and institutions. We have about 12,000 shareholders. We have management in the top 20, other management, board members who are in the top 20, or other shareholders that are classified as insiders in the top 20. But we've actually got a very, very long tail. We have a huge amount of retail shareholders, which we adore their support. They really get it. And institutionally, I'd say up until the last few years, it's graphite as a commodity and anode as a part of the battery has just been overwhelmed by what happened in lithium and sentiment. And so it's been a bit under the radar. But if you look at things getting published earlier this year by various groups, you'll see that's changing. Are we interested in recycling in, yeah, we are in Japan. Yes. It's probably no secret. Well, it's public that we have agreements with Altilium in the UK, and they're owned by, they have a large shareholder in Marubeni and also SQM, who are one of the world's largest lithium producers. It just takes a bit of Googling to see that groups like Marubeni, along with others like Hitoshu and Sumitomo and everyone, including, of course, customers like Toyota and Panasonic, are all involved in recycling programs as well. So there is definitely opportunity to take this to Japan. And I think currently there is some recycling in Japan, and we're quite familiar with some of those groups, but they tend to specialize only in production scrap, not used battery material. So yeah, there's an interesting interest in that. All right, that's my time up. Sorry, thank you. Really great to see you all. Thank you to OTC for running the event. And yeah, please, if there's any more questions, please reach out through our website and the contacts that will show up in a PDF of this presentation. It's been a pleasure catching up. Thanks all. Bye.